We're using a combination, in this case, of a lead section. That's the first part that goes into the ground, the one that's on the ground there in front, the 3 helix leads. Square shaft bar, in this case, it's an SS175, or it means 1 3/4 inch square shaft. It's a solid bar. And then we transfer to another 1 3/4 inch square shaft on the helical extension. So we're putting in those 4 plates. And then we transition to the pipe. So we have a special transition adapter that we add to the square bar, and then we can immediately add our pipe. Why are we doing that? It has a lot to do with the relationship of torque to capacity that is a well-known characteristic of helical piles. If you measure and determine the torque during installation, you can then use that as a way of a predictive capacity to determine and verify the capacity of the pile itself. It's an energy principle, much like driving piles is an energy principle. The reason we go from square bar to pipe, we call that a combo or combination pile, is that square shaft is a better penetrator into dense, hard, firm bearing soils. So it allows us to get the plates down into those good bearing soils more efficiently than if we did it with all pipe. The reason is that pipe has to displace a little bit more soil than the square bar does, so it takes a little more energy to do that, eliminate or overcome that friction, not eliminate, but overcome the friction, and so that you're actually applying a little more energy into doing that, which means your relationship is not as efficient as if you're doing it with the square shaft. So we use both because you want that maximum bearing strength or capacity with the square shaft, but the pipe attribute, of course, is that it's a larger section. It reduces or minimizes any concerns about buckling, or it also provides us with some lateral capacity. So this is kind of one of those piles that it's a hybrid, but we do it for specific reasons of performance of the helical pile.